So welcome everyone to the Ed Summit and to the session entitled Novel Approaches to Learning with Data. And I'm your moderator for the session, Michael Gould of Esri's education team. It's my pleasure to be with you for the next 45 minutes. We have three interesting talks, at least from what I've seen from the abstract. It sounds very interesting. Three different perspectives regarding learning with data. And so you can see the speakers' names here: Stephen Borders, Chris Saladin, and Maria Brown. So without any further ado, I will introduce Stephen. I've got my cheat sheet here. So Stephen Borders is an associate professor in the Department of Health Sciences at Coastal Carolina University, where he teaches courses in health data analysis and visualization. You have his title here, Visualizing Health Disparities with Dashboards and Infographics. So Stephen, let's see if you're able to take away my control, and the microphone is yours.
Okay, thanks. Can everybody hear me then?
Yes.
All right, wonderful. So thanks for having me this morning, or it's almost afternoon here on the East Coast. And so I'm going to talk a little bit about a project that I did with my students this past year in two public health classes. And also, I would be remiss if I didn't thank them for or recognize them for all the work that they did in this class as well, and kind of helping me think about this as well. So just sort of thinking about kind of what happened, and of course, 2020, 2021 were some strange times for sure. We had the George Floyd and Breonna Taylor murders and Black Lives Matter movement. And, in Coastal Carolina is about a third of our student population are persons of color. So it got me kind of thinking, too, about inequality, and especially in terms of health. And so what I wanted to do was not necessarily talk about it, but help the students kind of understand it and come to terms with inequality. And of course, part of that is some racial inequality in terms of health through this course. And then as we were moving through COVID and teaching remotely, of course, when your department head asks you to teach a GIS course online without being in the classroom, you kind of start scratching your head, especially if you're like me and you've always kind of taught either ArcMap or something like that, in the lab. So, that kind of presented a new problem for me. And then, of course, you're probably all familiar with the Johns Hopkins COVID dashboard. And I kept saying to myself, wow, that is really cool. And so when my department head asked me to come up with this class, I kind of talked to her about it and thought, hey, we'll do this dashboard design. And I thought that I could replicate at least the idea of the Johns Hopkins COVID dashboard with some of our own data. So just a little background about this too, and you'll probably wonder how we kind of pulled this off, and it took a lot of work in different ways and thinking about how to solve these problems. And so these are public health students, really no background at all in GIS, never taken a GIS course, and so that again presents its own problems in sort of thinking about it. So again, this move to the cloud, the software as service model. Is sort of how we adopted to this. So what you do need for this is an ArcGIS online organizational account. If you have an educational account, you have an organizational account. And only because we use a few credits. So you can do a lot of these things with the free account, but again, the organizational account is the best way because you have some greater capabilities there. We also use Business Analyst Online. And that's where we created the infographics. This uses a few more credits, but again, I think ESRI is pretty generous in the credits that they've given the university as part of our site license, and so it was never a problem. I think each student had 4,000 or 5,000 credits. A couple of times, a student will do something, and we were trying to be judicious about how we were going to use those, but they might expend more credits than they thought they had. And then the last thing about this too is that you need a website to host the infographics. And again, if you saw how Johns Hopkins did theirs, they had these really neat infographics that were part of that dashboard. And so what I did was that and again, I'm no web programmer at all, but I bought a little GoDaddy license. And what you need is the secure socket layer. So even though you can get a website for just a few dollars, you do need the secure socket layer, because that's what you're linking to, sort of a secure website. And when you're linking from that, from your pop-up in your dashboard, you need an SSL website. And that's sort of what costs a little bit more than just sort of these simple basic websites. So where we all started with this was this thing called the Healthy Communities Index. And the CDC has this really cool data set called the CDC Places data. If you're familiar with it, they changed it this past year, to the Places data. It used to be called the CDC 500 Cities. And so what it is this thing called the Behavioral Risk Factor Survey. And they look at things like binge drinking, do you get checkups? And it's done for adults, but they expanded it this past year to include all census tracts for the United States. So it's pretty cool. It's a really, really neat data set. And it has 27 measures in it. And so what we wanted to do was to reduce some of those. And that's sort of the idea of the index. You get kind of overwhelmed, sort of looking at high blood pressure. Did you get your screenings? Who had cancer, diabetes, obesity, those types of things. And just sort of came up with this idea of how do we do this community index overall. And it's just very simple idea where we just took the percentile ranks of everything for all 1,089 census tracts in Excel. There's a percentile function. It's pretty cool. There's the simple math of it. Again, anybody can do it and understand it. I did this first of all and created the layer and loaded that into ArcGIS Online. So that's kind of where we started. So here's just a quick graphic of what's in it. So again, you can kind of see, what's in the healthy behaviors, the healthy outcomes, and the preventive services. And so we had this overall index, the Healthy Communities Index, and then these three sub indices, again, based on high blood pressure, high cholesterol, kidney disease. So those are kind of outcomes, behaviors, smoking, obesity, those types of things. And then this preventive services index, taking medications for high blood pressure, did you get a cholesterol screening, things of that nature. So that's where all of this is. Again, a really cool data set. You can download it just a couple of moments. It's a wonderful data set, and I've used it, throughout for the past several years. It's been kind of a fun data set to explore. So the project, again, each student selected a South Carolina county to analyze a health issue from that CDC Places data. And really kind of what I wanted to do was have them make it their own. And by doing this, they added those social determinants of health. And we did those from the American Community Survey. So again, you can kind of think about the things that we had to talk about and understand and get an introduction to how to download some of that census data. But with the census, and then I have a link here too, if anybody downloads the PowerPoint slides later. There's a wonderful article that I saw in the Wall Street Journal, last fall about the predicament of counting Americans by race. And it was written by one of the old census directors. So it's a really interesting article, but it's kind of, really interesting take on that. So we spent some time talking about how we calculate race and ethnicity, and how to do those things, but also to understand and help students show some of these things about poverty, education, and how they affect overall health. So, we didn't spend a lot of time working with other tables because, if you get into the S tables, if you're familiar with those, the subject tables or the B tables, they really dive deep. And I think, what happens to especially novice students when they're getting into those, because some of those questions are so specific and drill down, there's often not good information at the census tract level. And so you have a lot of missing values. But the DP tables, the data profile tables, DP 2, 3, 4, and 5 are really a great place to start if you're introducing somebody to this. So again, the idea then was to create this interactive dashboard and infographic that analyzed a community health problem within their county. So there's a screenshot, and I think too that if we'll go here and I'll kind of drive this our one of the dashboards that I created, and so this was kind of the sample dashboard. And I know I always have my screen here that's anyway, it's some of the Zoom stuff's on here, so it's a little hard to show. But anyway, so what you're seeing is the index value. So this is the overall community health index. Red.
Steve, we're seeing the PowerPoint still.
Oh, I'm sorry. Thank you.
Maybe on a second screen, you need to drag it over or switch.
So let's do.
Happens to all of us.
How about that?
Here you go.
Okay, thank you. Sorry about that. So again, here's my dashboard. So again, red is sort of areas that are below average. Blue are the above average ones on our index. So 50, right, is about the middle. It's all relative based on the state of South Carolina. So, and what we did was, think about how to build these interactive dashboards, and that's what's really neat. If you go back and look at the Hopkins COVID dashboard, I was just sort of amazed at how interactive it was. And we kept looking at that and thinking about, how do we make ours more interactive? And so if you just kind of explore around here, you sort of see at this, this county level, and this again is Horry County. This is Myrtle Beach, Conway's here. This is where the university is. And I think, as you start looking and thinking about this, Tip O'Neill once said that all politics is local, but I think the same could be said for health, and that all health is local too, as we start looking and thinking about this. So we have a couple of things here on our dashboard. We have adult obesity, because obesity is a huge problem in South Carolina, and especially here in Horry County. And here's our index, and then this was the percent of adults with diabetes. So if you start, zooming around a little bit, you see that we have these values here to turn red. So this means that this is above the healthy people goal, the health and human services, healthy people. If you're familiar with that, they have these targets for which, we're trying to get lower obesity rates, lower diabetes, all of these sort of healthy goals. So this is how we were trying to add some context to help people think about whether or not these values were good or bad. So if you start, clicking around here and looking, here is, a track that's particularly bad, and we can select this in our dashboard updates. And again, we sort of see some of these select health indicators. In the obesity, about 40%, 16% diabetes, only 77% with a checkup last year, and about a quarter of the population without health insurance. And these were the data that we added here from the ACS, again, sort of thinking about how do we quantify, just sort of these simple racial and ethnic categories. And this is mostly this is a very rural area. So if we move around here too, we see this was one of the worst areas here in Horry County. And this one had a health index of 5.3, really high obesity rates, high diabetes, but about 80% with a checkup. Again, a quarter of the population without health insurance. And you can see that this group here, this census tract is mostly African American. So if I scroll down, then conversely, if we go to, one of these better census tracts, we see this one. And if you've ever been to Myrtle Beach, there's a really fine golf course here called the Dunes. There's some really fine homes here. And again, you see that this one has a much higher overall community index score, lower obesity rates, but still rather high on some things, but only about 11% of the population without health insurance. And we see here too that most of this group here is white. But I think, what was most interesting in what we did was that, and really where a lot of the work came from, was in building these infographics. And so, and again, these were built in Business Analyst online, and they're really, really impressive. So if we just sort of think about what we have here on the dashboard, what's really neat are these infographics. And I'll try and zoom up a little bit here. Let's see.
Steve, it's almost time to wrap up.
Okay. So anyway, so here is our infographic. Again, you can kind of see some information here about median household income. And you see that this one's pretty good. So each of these are neat. They're printable for every census tract. And again, if you go and look at some of these other ones that weren't so good, if I come back to, one of these, you can see the differences here. So much lower median income, high rates of disability, rather high rates of single female headed households, lower educational attainment, and poor health indicators compared to those. So again, thinking about adding some context there. And again, what's really neat about these is you can print these as well. So that's kind of, us in a nutshell. And I will cut it off there. And so we can probably take some questions. I guess, Michael, is that right? Maybe at the end, would that be the best thing?
I think we'll have to wait till the end. We're a little bit squeezed on time.
Yeah, and I don't
if you'd like, if you're happy sharing your email contact in the chat window, please do that so people can contact you outside of this session.
I will.
If not, thanks a lot. And rather than switching back to my slide, just to introduce Chris, why don't we have Chris take control? And while we're doing that, to save a second, I'll introduce him. So Chris Saladin is a history PhD candidate at the University of Minnesota, where he's taught courses in history and worked on an initiative to promote story maps across the College of Liberal Arts. So let's go straight to it.
Hi. So like you said, my name is Chris, and I am a history PhD student at the University of Minnesota, but I've also worked both as a graduate instructor and as an RA with this group called the Story Maps Curriculum Team at the University of Minnesota, really focused on sort of bringing GIS education into the humanities. And what I'm going to do today is talk about a series of assignments that I've worked with at the University of Minnesota that aimed at using Survey 123 as a method to sort of bring GIS and sort of education with data into the humanities classroom. So I'll focus on 3 courses, but start with a little bit of intro before that. Let's see. Okay. So like I was saying, I've worked with this group called the Story Maps Curriculum Team. And over the last few years, we've worked with dozens of classes across the University of Minnesota, largely in the liberal arts. And what we've really been trying to do is to get students and instructors who normally would never use GIS to use it in their classes. And we found that story maps generally was the best method to do this. It was a very it's a very approachable platform that enables them to sort of incorporate elements that they already know, text, images, other media, with maps. So we've done several of these assignments, most of which usually take the form of the sort of final project for a semester, where the student is sort of, instead of a paper, making a sort of interactive project. And this is our screenshot of our resource portal, which if you're curious about more about that project, you're welcome to go to storymaps.umn.edu, which has a lot more information about that. But the issue is that story maps also has a lot of shortcomings for trying to work with some of these classes, particularly the very, very busy larger classes. Story maps works great when we're working with, let's say, 20 or 30 students, but it's harder when we're working with a large class. And the biggest issue is usually with time. When you have a really busy semester that an instructor already has filled, there's sometimes not enough time to sort of dedicate time to workshops and other in-class work that is necessary to really teach how to work with and build these platforms. And then another issue is usually with group work. Story maps works well with up to, I'd say, 4 to 5 students, but then beyond that, it just doesn't work very well with lots of students trying to build one project together. There's sometimes some sharing access issues. Sometimes they override each other. And then sort of the other big thing that we found is sometimes a shortcoming is that story maps definitely has an emphasis more on the presentation of the story, sort of crafting an excellent multi-element interactive interface, but it doesn't necessarily have as much of an emphasis on the spatial data itself. And it can often be limited in terms of the maps that students are able to produce in these projects. So we use Survey123 as an alternative to story maps in the classroom so that students can sort of build these more visually and data robust projects. It's a much simpler interface. If you ever use Survey123, on the submitter's end, it's literally just a survey that they fill out and place a point on a map. And then the results of it are much more data and map focused. It creates a very quick spatial visualization. It can collect a lot of data from many more students. So this is very easy to do in a class that, let's say, has 50 to 80, 100 or so students. And it's really great for sort of working with a big data set with students who normally aren't working with a lot of data in a discipline like, let's say, history or something like that. And then what's nice about this too is that it's a collaborative, crowdsourced project of sorts. So it's not just a small set of students creating a project, but instead the whole class working on something together. Now I'll dive right into a few examples. This is an assignment called the What's Missing report that I worked on in a world history survey course that I taught. And this sort of had to cover a ridiculous amount of time. I had to go from the supposed beginning of humanity to the year 1500, roughly. So we were covering an insane amount of material in the course and had to make cuts to so much history. And so we came up with this idea that to sort of make up for those gaps in history, we would have students sort of submit reports of things that we didn't cover. They would have to do outside research and write up a report on that and submit it to this collaborative project, and also make an argument for why they think that should have been included in the course. So this was a decently large class, 50 or so students. And over the course of the semester, they made 12 entries via Survey123, which they just conducted their own independent research online and through the libraries. And then they sort of submitted that information through the survey. So they moved from the survey. The students just interacted with the survey. That's where all their data entry happened. And then I took that data that they entered and created maps within ArcGIS Online, creating layers for each week's material, made a custom base map and formatted it to show the labels. And then I moved that into a story map that collectively had all of the projects for that class that then all of the week submissions for that class so the students could look through and see all the projects. And overall, this worked extremely well. On a basic level, it really got the students to focus on their web writing. And it really got them to sort of boil down sort of their argument for why this material should have been included in the course. So this was, in a lot of ways, this was very focused on actually the sort of text answers in this project for this assignment. But it also produced this map where basically the students literally filled in the geographies that we weren't covering as well. So there was a lot of areas of the world, particularly, let's say, in like the Americas, and then also in Africa and places of Asia that might normally get left out of a sort of classic Western Civ class, that the students themselves sort of took the initiative to fill in, while also filling in some more sort of traditional historical details. But we got a very sort of widespread map that allowed the students an actual role in creating the course narrative. They got to create a visualization of the history that they thought mattered in the time periods that we covered. The next assignment that I want to talk about was one done in an ancient Greek history course. And this had about 60 students in it. And over the course of the semester, students submitted 7 different entries that all had very specific prompts. And in each case, there was sort of a designated topic, and the students were all assigned specific places ahead of time. They were sort of given a spreadsheet with their name and the place they needed to map. And then they worked with a particular source, usually an actual primary source, an actual ancient text or something, that they were then sort of using for the info to then go and sort of contextualize that in geography via the survey. So, like I said, they moved from this list of places into the map. In this case, I guess I should have mentioned this particular entry I'm talking about. They actually mapped Homer's catalog of ships, which is from the Iliad, the very famous epic. If you've ever read the Iliad, in book 2, there's this terribly boring list of just names and places that goes on for like 300 lines. And most students just skim right over it, rightfully so, because it's very boring. But we took that list and made them map all the places listed in it. And so this is what the students were able to produce. They basically created a visualization of what Homer is describing as being all the places that brought ships to fight in the Trojan War. So all of a sudden, this boring list becomes this visualized sort of ancient imagined geography. But what was cool with this is we were also able to visualize that same data in different ways. So they entered the number of ships that each place brought, and we were able to show that as a heat map. So then when you look at this instantly, you have an idea of those particular regions of Greece, which were actually contributing the most ships according to Homer and are kind of the most important in the text. So we did some other visualizations as well, but overall, this was a really interesting way to visualize an ancient text in an interactive spatial interface. So the last one I want to talk about real quick was an assignment done for a History of Modern Japan course. And for this one, students mapped US air raids on Japan during World War II. And for this one, the students were actually working from data that was drawn directly from an archival, a government report from the Japanese government, from an actual archive that the TA for the class translated from Japanese into English for the students and then put it in a spreadsheet form for them to access this data. And this was the actual report that was assessing the damage of these air raids that the Japanese government did right at the end of World War II. And so they moved sort of from working with those numbers that came out of that report and then plotted all those on a map. Once again, students were assigned an individual place, had to research a little bit about it, and then input the data that they were given from this along with their own sort of research into that place's history. And you can see that it produced sort of this image instantly of just all the places that were bombed. But what's even more interesting about this project is that then we could again visualize that in multiple different ways. So then we took sort of the population numbers, for example, and you can see what are kind of the main Japanese cities. But then we moved to the casualty rates. And you can see that roughly they do correspond with the larger cities. There's a few exceptions. You'll see that Hiroshima, for example, obviously has a lot of deaths because of the atomic bomb dropped there. And then we also visualized the population relative to the casualties, so a sort of per capita casualties. And you can see that instantly Tokyo shrinks in size because it's a much larger city, but a place like Hiroshima stays. The damage is large. So I'll just wrap up real quick here. Basically, the takeaways for this are that we've conducted assignments like this in other classes, and in each case, they've all been very successful. I've worked with a Spanish class on this. I've worked with a Christian history one, a medieval history, mostly history because I'm a historian. And in all cases, it works very well. There are some limitations in that it can be time consuming on the instructor, whoever's creating the data, to prepare the maps. It's easy on the student end, maybe a little more work to prepare that data. And so usually instructors need some sort of assistance in doing this. But for more examples and resources, please go to the website storymaps.umn.edu, which is the sort of resource portal that my colleagues and I have put together. And you'll find more info there. That's all. Thank you.
Thank you, Chris. And we've had a request for your presentation. So if you're comfortable adding a link or just providing your email address for a contact, that would be super. And
absolutely.
We're, again, a little bit squeezed on time. So let's see if Maria can take control.
Hi, everyone. Can you see my screen?
Okay. Yes, let me give you a quick introduction. So Maria Brown is a lecturer at Stony Brook University since 2011. As part of the Global Bat Taxonomy Working Group, she's created a GIS internship program mapping over 1,400 bat species for batnames.org. So very interesting topic. Take it away, Maria.
Who doesn't love bats? Well, some people maybe these days. But hi, everyone. I'm Maria Brown. I'm from Stony Brook. Today I will talk to you about how we created, or how the students really created, this integrative maps for bats of the world. So let's just see if I can get this go. Okay, so I'm going to talk to you basically about the scientific and geospatial problem that came about in 2016, how the students created this design, what the outcomes were, and what our future work is right now. So there was this bat map dilemma in the research community for the bat community. And every 3 years, we have an international bat research conference. Durban, South Africa is a great place for a conference. Just saying, Esri, you might want to do that once in a while. It's a cool place. But we were here, and Nancy Simmons, who is the curator of mammalogy at the American Museum of Natural History in New York City, she's basically the queen of the bat world, and she's the one who puts the final stamp on, yes, this is a new species of bat, no, this is not. And so each year at either the North American Society for Bat Research or the International, she will wear a t-shirt that reveals the newest number of species of bats. And so this one was 2019, where we were still at only 1,411, but she keeps declaring new ones every day because of advances in genomics. So she comes up to me and she goes, hey, we're having this IUCN Global Bat Taxonomy Working Group meeting. We have a couple of mapping questions. We'd like to invite you to come to the meeting. And I said, oh, okay, well, that's good if you have mapping questions, because I can basically tell you a wing from a leg and don't really know much about the taxonomy of bats. And so she invites me, and you know how it goes. Like you say, all right, I'll be back in a minute, run to the ladies' room. I came back, they had a board meeting, and apparently I was voted onto the board. So don't ever disappear from a working group meeting, because when you're the only geospatial person in the room with a bunch of scientists, they're going to nominate you to the board. So she's like, we have this problem, and it's mostly based on problems where the older or more senior bat scientists, they're the most amazing field scientists, but they haven't ventured into the world of geospatial science. And the younger scientists and the PhD students are all, sorry about that. Well, they all want to learn geospatial science. So I started doing breakfasts with GIS, and all of these students would come and they'd ask for suggestions for their PhD projects. But the problem was batnames.org is this website. It's supposed to be the one-stop shopping website for bat scientists. And there's all the peer-reviewed literature, and there's supposed to be these maps that are supposed to help the younger generation kind of get best data availability for their research if they're doing some sort of geospatial analysis. And what we noticed in a lot of the conferences is that the students didn't really have a strong enough background in GIS, so they weren't vetting through the data correctly, and their outcomes for their research were probably skewed quite a bit. So weren't really presenting findings of what was best represented on the ground. So that we have this visualization problem. And so here's a really cool bat. It's the Peter's ghost-face bat, Mormoops megalophylla. And this is just showing the GBIF data. So Global Biodiversity Information Facility, some of you may have used GBIF data, but there's a combination of it coming from scientists and from citizen science, where and then there's somebody that it just goes by Jack the Batman. So you don't know if it's good data or not. And so they have to know how to basically say, okay, do I have good data or don't I have good data? But the IUCN Red List wanted to have their polygon data sets used as well. So for batnames.org, the question was, how do we combine these data sets, and how do we let batnames.org represent the best representation of where bat distribution truly occurs? And so this is where we really wanted to get to for what would appear on batnames.org. So we have the observation GBIF data sets, but then we also have the extents. And this one, this boundary layer here says Rojas et al., and it's not the IUCN Red List data. It's because this is the best polygon data set in the peer-reviewed literature, which is updated most of the 2008 or even 2016 polygon data sets. So this was the goal of where we wanted to be and where we wanted over 1,400 maps to look like, or what we wanted them to look like on the website. So how do you actually get to that point? The goal was, right now we have 1,437 plus species. And so we wanted to know how to provide the most useful data for these young bat scientists. And then also, how do we do this with over 1,400 species and me keep my sanity? So we find a small army. And that small army was a combination of undergraduate students and graduate students that had specific roles to come up with the actual design, formulate protocols that future research scientists under me could carry out this long-term project. And so we have team leaders, and one of the team leaders' responsibilities is to go to the website, check out the peer-reviewed literature, and find out if there are more updated polygon data sets than what is available for IUCN. We have a Python code specialist, Alina is great. So we have a combination of students that are in the School of Marine and Atmospheric Sciences, Ecology and Evolution. We have students that are from computer science, and then we have master's students that are getting their geospatial certificate. We had students that were just downloading the GBIF collections and just downloading the IUCN Red List collections. And then we had our mapping specialists, those students who are actually creating the maps and putting together the symbology or standardizing the symbology. So the students came up with the process, basically downloading the data sets, using ArcGIS Pro, preparing and processing the XY GBIF data, and then putting together the polygon data sets, and then creating those new features from the sources. And one of the things with the GBIF data is they have to take subspecies and bring them in and merge them with the species. So in order to keep it as simple as possible, we would keep the subspecies with species. And then we needed to remove redundancy in all of the different layers. So they would remove those redundant points and then standardize the symbology and prepare to move the data to ArcGIS Online so we could push it to the web and get it up on batnames.org. So this is just what GBIF data looks like. You create a free account. The students then can figure out how to download the data. We would keep a spreadsheet going. We knew exactly where the what the URLs were for these downloads, and this would all then, they would have to keep track of all of this to put into the metadata, because they had to design all the metadata and the protocols for the metadata as well. And so then they would go and get the spatial download data from the Red List, or we would be getting the data from the most recent peer-reviewed literature and contacting those scientists to get their data sets. And so we would be going from this GBIF data, which this is coming right from the Bats of the World or the batnames.org website. This is what appears on most of those species right now. And the goal is to get to that one. And so they would prepare that XY data, they would create the layers, and they standardize the symbology, and then remove that redundant data, and then create their symbology. So everything was standardized for that symbology. These are what they chose to use. And then we would make, they would set the extents for auxiliary sphere for web mapping. And then they would create the layer properties, and this would become part of their metadata. So create the metadata, create the web templates, and then share with the public. And then the URL that's created then would go to the American Museum of Natural History. So they produce their flow, their model, and they would validate that run. And then they would go in and edit pop-ups, because there's so many different attributes that could be presented, but we really didn't want all of that information. A lot of it was not necessary for that particular visualization on batnames.org. So, we would have just key attributes that would show up in the web map. And so Andrea Cirinello, she designed the whole web page, and she would do her web magic for the batnames.org website. And so if you click here, it'll bring you to the Mormoops megalophylla, but just to save some time here, since I know we're running short on time, when you type in Mormoops megalophylla on the website, this is what comes up. It'll give you all of the information. It'll give you the most updated articles. And so this is where my students were looking for the most updated research to see which polygon layers we were using, whether we were using the IUCN Red List or if we were using peer reviewed. And so here's the map, but you can then click on the map and you can see a larger view of it. And here is one. We left this here because this is clearly an outlier. This one should not be here. And so what you can also tell with this is that, wherever the distribution polygon maps are, we're then seeing these other species that are falling outside of the known distribution. And so this creates questions for young scientists to say, well, why are they? Is this where we need to start looking at some genetics work? Or are these actually different subspecies? And so when you have the best data available for these young scientists to start asking questions, it's really important for them. And so here we can go to the details, and they can go and they can see where the data came from. And here's where all of the metadata for the maps come from. So that is the goal now, to get all of that up and running on the batnames.org website. It has been completely designed by students from Stony Brook University. And that's how we're creating all of these interactive web maps. So on the web map, you can actually click on it and you can get all that information that you want. But also the students this summer now, we have about 800 of the maps completed. And I have another small army that are part of the quality assurance, quality control team. And they are now verifying that all of the data that went in based on the spreadsheets that were kept by the students that created the original maps, now that everything gels, and we'll be able to get that data up to batnames.org. So we created those, kind of kept my sanity. I'm still here and still managing it. Somewhere along the way, we did find the Blind Bat Brewery on Long Island. So the students found that and were very happy to share that with me. So we did, in the end, go out and have a beer at the Blind Bat Brewery to celebrate the maps that they did. So I would like to thank you. Again, student created, working with American Museum of Natural History, working with the IUCN Red List group, and they interfaced with all of these people along the way. So it was a really great experience for young students to be able to interface with some of the top bat scientists, even if their expertise is in computer science or it's marine science. They were still working with bat data. And so taking all these it wasn't their own data, but taking other data, learning the importance of really going into the most recent peer-reviewed literature to find out what the distributions are, and then being able to ask questions in the future for better research. So thank you. I thank Nancy Simmons from the American Museum of Natural History and Andrea, and then of course the students for just being so creative, and so they just persevered and were so persistent on getting all of these maps done. So if anybody has any questions, I'm sure we'll do a question answer, but thank you so much.
Well, actually, we're so pressed for time in these short 45-minute sessions. I was wondering if you're comfortable adding your email address there in the chat window. People can contact you. Lots of comments here about how awesome the project is, and people asking for ideas for chemistry and physics, and yeah, just never have enough time for the deep conversations in these sessions.
Right.
So if you'd like to share your email, then please do so before we get kicked out of the room, because there'll be another session coming along very soon. I'd like to thank all three of my speakers. So thanks to Steve, and thanks to Chris, and to Maria. 3 excellent talks, 3 very creative ways of using spatial data and bringing GIS to what I would call non-traditional GIS students. So not your typical geography student. Interesting group of learners and data sets. And so thanks, Maria, for adding that the email address. And thanks to everybody for joining us. And hope you enjoy the rest of the summit. And if you need to contact us, please track us down during these next few hours of the summit.
Thank you, Michael, for hosting us.
Yeah, my pleasure. Bye, everybody.
Bye, everyone. Thanks. Enjoy.